Now we have Dr. Kwong, which will present the next paper about the effect of laser-induced periodic surface structures on nylon fabrics. Dr. Chan is Associate Professor of the Institute of Textiles and Clothing, specializing in quality management and textile materials modification.
Sorry, I'm late and changing my schedule. Sorry about that. And so, good afternoon, ladies and gentlemen. Today, my presentation topic is the effect of laser-induced periodic surface structures on nylon fabrics. So, my presentation content will be divided into 5 parts. So actually, include the introductions, experimental design, results and discussion, and conclusions. And of course, finally, will be the Q&A. So for the introductions, so this laser. So we start with a brief introduction. So the surface properties of polymers are often the important determinants of their usefulness. Many of these chemical treatments now in use are aimed at modifying these properties. Of course, the UV excimer laser is a technology which can be produced not only interesting morphological modifications on the surface polymer, but also can replace the less environmental, blankly finishing process. So the laser-induced periodic surface structure, simplified as LIPSS, are widely studied recently. And so depending on the laser fluence used, the study of the LIPSS on certain polymer material can be categorized into high fluence, that is the laser fluence above the ablation threshold, and also the low fluence, that is the laser fluence below the ablation threshold. And the low fluence laser irradiation can be generated by a linearly polarized laser beam with 1,000 pulses. Here the figure shows the low fluence laser setup. And this is a polarized laser beam, and we irradiate the samples with 1,000 pulses. And it is found that the sub-micron structures form in a narrow fluence range. About the experimental design. So nylon 6 plane movement fabrics are irradiated with the LF examiner laser at the wavelength of 193 nanometer, and the scanning electron microscope, and the X-ray photoelectron spectroscopy, and the differential scanning colorimetry are used as the characterization techniques. So to test the fabric's properties, we have several light wettability, fabric lustrous, air permeability, and thermal property will be determined. And so how low fluence UV laser modifies these nylon fabrics? And firstly, we will discuss the morphological changes. So actually, the scanning electron microscope helps to study the changes in morphology. In this figure 1A, when the laser fluence is mj is applied to the sample, no structuring can be observed. And for the high fluence, 20 mj, the melting occurs on the surface of the sample. Of course, we have one between. Between this fluence, let's say, is about 13 mj, some sub-micron surface structure form. So here, some stripe in a nanometer size form on the sample surface, and therefore the sub-micron structures only form with a narrow fluence window. So for the changes in the chemical composition can be studied by XPS, and the Kwong table shows the XPS result. And from the result show that this oxygen to carbon ratio and also the nitrogen to carbon ratio increased significantly, but reversed to the lower level after irradiated to about around 2,000 pulses. So the increment in the oxygen to carbon ratios clearly show that the surface has higher oxygen content than prior to irradiations. And the results are due to a subsequent reactions of the laser irradiated surface with the atmospheric oxygens. For this figure summarizes the carbon signals of the XPS spectra. And it can be observed that the relative peak areas of the subcomponent change significantly after the laser treatment. So after the low fluence laser irradiation, the carbon 2 and carbon 3 component decreases. And it is also observed that the carbon curve rises from its minimum at about 2x6 EV after the treatment. And this new peak at 2x6.55 EV can be assigned to carbon 5, that is the COH peak. And therefore we propose that part of the hydrophobic groups in the nylon, such as the CH, CC, and CN, were transformed to the hydrophilic groups after the low fluence laser irradiation. The DSE study shows the changes in crystallinity. So it is found that no significant change in the crystallinity of the laser irradiated samples. That means the laser treatment is just a surface treatment which does not affect the fiber bulk properties. So for the, let's discuss the fabric property. So first of all, the fabric wettability. The nylon fabric irradiated with a low energy dose result in the improvement of the fabric wettability, but tend to reduce with the increasing numbers of laser pulses. The result can be attributed to increase of the surface oxygen by the laser treatment. Second, for the fabric surface luster. The figure shows the schematic glossiness distributions of untreated and laser-treated nylon fabrics. And so the blue lines is the control. The laser treatment results in a decrease of the glossiness of both the wet and warp directions with an increasing number of pulses. And this is due to the sub-microstructure diffuse the incident light. Although this laser irradiation decreases the fabric glossiness, the laser-treated fabric diffuses the incident light more evenly. And therefore, this helps to improve the appearance of synthetic fabrics and makes it more like natural. The other fabric property is the air permeability. So the air resistance in the units of kPa as per meter is recorded. And the figure indicates that the lower fluence laser irradiations slightly increase the air resistance of the fabrics. And the laser irradiation induces certain roughness which act as a boundary to hinder the airflows through the fabrics. And so we expect the air permeability of the laser treated fabric will decrease slightly. And for thermal properties, so the warm to cool feeling reflects the heat loss per unit area under the conditions of 10 degrees centigrade temperature difference. The value of the laser irradiated fabrics decreased slightly. So that means the treated fabrics have better warmth retention property compared with the control. And the laser treatment increases.
Excuse me, can you please put the mobile off, please?
So the laser treatment increases the fabric surface roughness and therefore increases the amount of trapped air between the yarns. Of course, the air is a good insulation medium. Increase the amount of trapped air will improve the warmth retention properties of the fabrics. So it's time for me to make the conclusions of today's presentations. The modification induced by excimer laser with the energy region below the ablation threshold on nylon 6 fabric has been studied. And the surface analysis techniques demonstrate that the sub-micron structure formed on the nylon surface within a narrow irradiation energy region. And the irradiations of fabrics has been found to improve the hydrophilicity. And the surface appearance of the irradiated fabrics can be modified to more like natural fabrics. So this work suggests that a careful selection of the laser parameters to form sub-micron surface structures, such as energy regions and the number of pulses, are of primary importance. And the treatment can be used to increase the values of textiles and apparel products. As the laser modification process does not involve any solvent, it is regarded as an environmental friendly process. Thank you.
Any question?
Thank you for your very good presentation. I'm just wondering about the increase in notability due to the laser modification. Can you explain this? I think it depends on chemical nature of substrate, not on its physical form.
Actually, I did investigate how these chemical constituents affecting. One of the situations is the stripes occur of the material. We find that one of the control parameter will be the laser beam effects. And of course, the sort of orientations of the molecules of the fiber doesn't affect too much on that properties. That is one of the crucial points. Of course, if you increase the laser energy to a certain extent, then you may have a reverse properties. One of the basic idea of doing this, of course, we have some continuity on that, is the sort of instrumentation and characterization techniques that make it a crucial point for the investigation. So we are looking for some of these, like the seams, probably can give some of this answer, and also the AFM. So this is what we are trying to do.
Any other questions?
Those structures that you induce on the surface, if you were to heat set the nylon, would the structure still remain?
Yes, of course. Of course, until it depends how high the temperatures. If within the transition temperatures, it's
Normal heat
not
set.
be melted.
And also, is this an economical process?
I really think so.
Is there any possibility of the gentleman was asking, is it the chemical or physical cause of the increase of hydrophility?
Actually, this is the laser effect which generate heat, a thermal effect, and also, as we found that, the increase of some of these, like the oxygen groups and all that, will affect the chemical natures of the fiber. So the hydrophobicity of polymer can be reduced and changed to hydrophilicity. So you can say this can be a physical induced chemical effect on the material.
I think it might prove by time that a certain physical influence is there.
Yeah, yes, of course. Yeah.
Not a little, not a little. I think that the physical is obvious.
Yes.
Possibility of physical is obvious and it needs more investigation.
Yeah, yeah. Actually, we are looking at both directions. Maybe the combinations of these physical and chemical effects will be, maybe we've got a wide range of study in the future.
Thanks, Dr. Chair.